Good morning, students. Jai Swaminarayan. We have discussed the basics of combination. Students, in the previous lecture, we have discussed the basics of combination, which once again, students, I am discussing. And then, students, we go for the sums. Now, students, what is the definition of combination? The total random selections of r things out of given n things are called combinations of r things, denoted by, students, NCR. And the formula for NCR is n factorial upon r factorial into n minus r factorial, students. What was important in permutation, the same thing is not important in combination, and that is nothing but, students, order. Combination is understood by the words selection or draw. That indicates NCR, and ordered arrangement indicates the use of permutation, and that is nothing but, students, NER. So this is what, students, you have to remember and memorize. I have been repeatedly telling, in examination they will not inform us whether this is a sum of permutation or combination. Okay, next important formulas: NC0 is equal to 1 and NCN is equal to 1. Given 5 things, you reject all. That can be also done in one way, and given 5 things, you select all. That also, students, can be done in only one way. So, in general, NC0 is 1 and NCN is also 1, where definitely N is a natural number. Then, students, NC1 is N. Given 5 pairs of shoes and you have to select any one. You have 5 options. Out of 5 pairs of shoes, students, you can select any one. So in general, NC1 is N, 10C1 is 10, 8C1 is 8, 25C1 is 25. Then, students, NPR is equal to r factorial into NCR. When you multiply combination by r factorial, we get permutation. Then, students, NCX is equal to NCY. It implies either x is equal to y or n is equal to x plus y. This is one of the most interesting property of combination, students. This is one of the most interesting property of combination. And last but not the least, NCR plus NCR minus 1 is equal to N plus 1 CR. So, students, these are the basic properties of combination, which are very important as far as sums are concerned. Now, I do the second sum of main question 2. 2NC3 is to NC3. 7.4 main question 2 part 2. 2n C3 is to NC3 and that is nothing but 11 is to 1. Then students need to find. This ratio is given as students 11 is to 1. In this condition, students, we are supposed to find n. So apply the formula of NCR. Instead of n, we have 2n. So this works out to be 2n factorial upon 3 factorial into 2n minus 3 factorial upon n factorial upon 3 factorial into n minus 3 factorial, and this is equal to students 11 is to 1. This students we have to remember and you can say apply. Now I will reduce 2n up to 2n minus 3. First of all I cancel 3 factorial. So 2n minus 1, 2n minus 2, 2n minus 3 factorial gets cancelled, n minus 1, n minus 2 and n minus 3 gets cancelled. This is very important logic students in simplifying the sums of permutation and combination. Students, what is that technique? What we adopt is that we simplify the higher factorial term and reduce it up to the lower factorial term and get it cancelled. First of all, n and n cancelled, take 2 common here, so we will get 4 into twice n minus 1 into n minus 1 upon n minus 1 into n minus 2, and that is 11 is to 1, so n minus 1 gets cancelled. So this is how students we simplify and cross multiplying. We get 8n minus 4 is equal to 11n minus 22. So 3n is equal to 80. So n is equal to 6. This is the answer. So the simplification logic is to reduce the greater factorial terms up to smaller factorial terms and students get it cancelled. Okay students, now we are doing the third sum. Students, now we are doing the third sum. A circle is given students which has 21 distinct points. Say answer 3. A circle is given and this circle has 21 distinct points. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, so 21. Now, what is told? How many chords can be drawn through 21 distinct points on a circle? Chord. Students, what do you mean by a chord? A line segment joining 2 points on a circle is a chord. So if I join 1 and 3, this is a chord, say 18. If I join 4 and 8, this is a chord. I join 18 and 11, this is a chord. So chord is a line segment joining 2 points on a circle. Now students, out of given n things, if you select any r things, it can be done in NCR ways. Say given 5 pairs of shoes and you select any 2 pairs of shoes, it can be done in 5C2 ways. Given are 8 different things and you select any 4, it can be done in 8C 4 ways. So the number of chords indirectly means selection of 2 points. The number of chords indirectly mean selection of 2 points out of 21. So number of chords using number of chords using 21 points is nothing but 21C2, because at a time from 21 distinct points to form a chord, students, we need only 2 points. So when I simplify this is reduced to 21 factorial upon 2 factorial into 21 minus 2, 19 factorial. So this is reduced as 21, 20 into 19 factorial upon 2 factorial is 2, 19 factorial gets cancelled and number of chords works out to be 210. So how many distinct chords can be obtained using this 21 points? Then students, the answer is 21C2. What is the answer, students? 21C2. And 21C2 works out to be, students, 210. Now, students, in permutation and combination, another important aspect is and or theorem. Students, another important aspect of permutation and combination is and or theorem, which you have to remember. For and, we go for multiplication. For or, students, we do add. Means we do addition. So, and or theorem is an important aspect of permutation and combination. Now, what we are given? In how many ways a team of 3 boys and 3 girls will be selected from 5 boys and 4 girls. So 7.4, answer 4. We are given 5 boys and 4 girls. Students, we are given 5 boys and 4 girls. From 5 boys we have to select 3, and from 4 girls also we have to select 3. Selection, students. Once again, try to recognize the words. We are here aware of that this exercise exclusively belongs to combination, but students, in examination it may not be the case, so be very careful. So a team of 3 boys and 3 girls can be selected in a team of 3 boys and 3 girls can be selected in 5C3 out of 5 boys and 3, so 5C3 and which into out of 4 and 3 girls, so 4C3. So this is 5 factorial upon 3 factorial into 2 factorial, and this is 4. Now here there is a shortcut. Try to understand. In MCR, the answer is n when r is 1 less than n. So when r is 1 less than n. So suppose 8C7, then the answer is 8. 9C8, then the answer is, students, 9. 10C9, then students, the answer is 10. So 4C3, the answer is students 4. Now, reduce 5 factorial up to 3 factorial. 5, 4, 3. This is 3 factorial. 2 factorial is 2. 3 factorial gets cancelled. 2, 1 factorial, 2 are 10, and 2, 4. 40 ways, students. In 40 ways, we can select a team of 3 boys and 3 girls from given 5 boys and 4 girls. So this is very simple once we understand, students. Find, okay, now question 5. Find the number of ways of selecting 9 boys from 6 red, 5 white and 5 green. We are given 6 red. Answer 5. We are given 6 red, 5 white and 5 blue balls, students. This is given to us. Now we have to select 9 balls under the condition that we have 3 balls of each color. Under the condition that, students, we have 3 balls of each color. So from 6 red, I have to select 3 red. From 5 white, I have to select 3 white. And from 5 blue, I have to select 3 blue. So total ways of selecting 9 balls such that we have 3 balls of each color is equal to. Statements are very less, students. Here, statements are very less. But the main aspect is to apply the concepts of, students, permutation and combination. So we have 3 red and 3 white and 3 blue. This will be more, you can see, easy to understand. Now from 6 red, I have to select 3. So 6, C3 and C3. So and over here is a master key in permutation as well as combination, students. And or theorem is a master key, students, in respect of permutation and combination. From 5y any 3 and means into from 5 blue any 3. Now simplify this. So it will be 6 factorial upon 3 factorial into 3 factorial, 5 factorial upon 3 factorial into 2, 5 factorial upon 3 factorial into 2 factorial. Now students, by this time, all of you must be well versed in the application of the formula NCR. Now students, at this level, I wouldn't be happy to simplify the formula in detail NCR. Now reduce 6 factorial up to 3 factorial and 1 3 factorial gets cancelled. So 6 by 4 and 1 3 factorial is 6. Reduce 5 factorial up to 3 factorial gets cancelled. This is 2. Same here. So 6 and 6 gets cancelled here. We cancel 2. 20, 10, 10. So it is 2000 ways. So in 2000 ways, quite a large number. In 2000 ways, take, students, such that we have 3 balls of each color from given 6 red, 3 white, from given 6 red, 5 white and 5 blue balls, students. So this is how we apply and/or theorem. Okay, students, now we do sum number 6. Okay, students, now we do sum number 6. Determine the number of 5 cards combination out of a deck of 52 cards if there is exactly 1 ace in each combination. 5 card selection, students, without playing cards. The sums of probability and permutation combination remains ununderstood. Say in a pack of 52 playing cards, students, let me tell you, we will discuss the basics. We have 4 suits, say club, then spade, then hearts, and the last is diamonds. So, in a pack of 52 playing cards, students, there are 4 suits. Remember this. These are the basics of playing cards, and this every child in permutation and combination must understand, because this is directly applied in probability. We have 13 cards of club, 13 of spade, 13 of heart and 13 of diamond. 26 cards are black color cards. And this 26 cards are red color cards. This you should remember. Now in 52 cards we have 4 jacks, 4 queens and 4 kings. And these 12 cards are face cards. Remember, ace does not have a face. Ace is the highest level card, but it does not have face. So 40 are non-face cards. 40 are non-face cards. Remember, students, any ace doesn't have a face. Students, ace does not have a face. So this, students, we cannot let it be, we can say, ununderstood. Okay, so this was the basic of playing card. Now from a pack of 52 cards we have to select 5 cards. So what I am doing, as per the sum, 52 cards are divided as 4 and 48 others, where we have exactly, you can say, 1 ace in each combination. So 4 ace I separate out. Now we have to select a combination of 5 cards. So I am writing the number of ways of selecting 5 cards which contains 1 ace is equal to exactly 1 ace. Means we shouldn't have less than 1 or more than 1 ace. This combination must have exactly, students, 1 ace. In how many ways, students, this can be done? Now from 4 ace I have to select any one. So 4C1. So from 5, one card is already selected. Remaining 4 from 48. So 48C4. Because our 5 card selection must exactly have students 1 is, and you can say for remaining 4 cards students we do not have any instruction. So now 4 NC1 is n, so 4C1 is 4. This is simplified as 48 factorial upon 4 factorial into 44 factorial. Now 4 factorial is 24. Reduce 48 up to 44 and get it cancelled, and this is 24. Now simplifying this, students, answer is 778,320. 778,320. 7,78,320 ways are there in which we select 5 cards which exactly contains 1 ace. And once again, an ace doesn't have a face. Remember this. Remember this basics of playing cards. Without playing cards, sums of permutation and combination as well as probability cannot be done. Okay, now we are doing 7. In how many ways can we select a team of 11 players? From 17 players in which only 5 players can bowl. Okay. Total students, answer 7. Available players are 17. And out of 17, exactly 5 are bowlers and 12 others. For this 12, we don't have any instructions. So they can students, batsman also, all-rounder also, fielder also, wicket keeper also, students. We don't know. So for other players, students, we do not have any instruction. But we have to form a team of 11 which contains exactly 11 or 4 bowlers. A team of 11. And condition is 4 bowlers. These are the sums of conditional combination, students. As we have the sums of conditional permutation, students, these are the sums of conditional combination. So a team of 11 exactly containing 4 bowlers. So we write the number of ways in which a team of 11 players be selected which contains exactly 4 bowlers, means neither less than 4 nor more than 4. So from 4 bowlers can be selected in 5C4 and remaining 7 can be selected from 12 because we do not have any condition for remaining students 7 players. Now 5C4 is 5. I just now told when R is 1 less than n, answer is n. This is 12 factorial upon 7 factorial to 5 factorial. Simplifying now, I assume that you know the simplification. Final answer is 3960 ways. So, the number of ways in which a team of 11 players is selected from given 70 such that exactly we have 4 bowlers is nothing but, you can say, 3960 ways. So students, last questions we will do in the next lecture and then complete the chapter. So students, I hope now all of you understood the basis of permutation and combination. Combination is always understood by the word selection or draw. Permutation, students, is always understood by the word arrangement. So you yourself has to decide in the examination or test whether this is a sum of permutation or combination. Students, hint will not be given. Once again I repeat, no hint will be given, students, in the examination whether this is a sum of permutation or combination. Next important aspect is AND OR theorem, students. Check. The next important aspect is AND OR theorem. For AND we execute arithmetic operation multiplication. For OR, students, we execute the arithmetic operation addition. This also, students, we have to apply. Not only understand, students, application. Application of AND OR theorem is more important than understanding, students, what is AND OR theorem. This last property, NCR plus NCR minus 1 is equal to N plus 1 CR, students, we haven't applied in any of the sum. But for your knowledge, this is a very important, or this is an important property for chapter 8, which we are going to start after completing, students, chapter number 7. So students, we conclude the lecture. Remaining we will do, students, in the next lecture. Thank you, students.